Right, we're moving on to our next session about artificial intelligence and the future of warfare. And AI has become this phrase that is deployed all the time in all kinds of contexts, both positive and negative. It's a rapidly developing capability. It promises to change the face of warfare for years to come. And we'll hear now from experts in defense technology about how we can use it to revolutionize the way we make decisions, how we harness intelligence and data, and how we defend against future threats. In this panel, we also are making time for audience questions. So if you're watching remotely, you could submit them, your Q&As, just follow the instructions on screen, and we'll try and get some in the last few minutes of this session, so on the platform that you've got online. So let me introduce my guests. I'm joined on stage by Mark Seward, the Chief Technology Officer of Kinetic, a British multinational defence technology company. I'm joined as well by Nabil Lodi, the Chief Executive of NVIDIA, a software and services company which works with the Royal Navy and BAE on the Royal Navy's digital platform, Project Nelson. We're also joined by Alan Varker, who's the Strategy Director for Leonardo Electronics Division UK, who has over 40 years of experience in technology and capability development for the multi-domain environment. And remotely, we're joined by Paul Gosling, who's here in the UK. He's the Chief Technology Officer at Thales and has around 25 years experience in sonar naval sensing systems. And we're also joined by Dr. Neta Eza from the East Coast of the United States, who's the Corporate Senior Manager of Strategic Planning at Northrop Grumman. And she's also the AI Architect for the Northrop Grumman AI campaign. Welcome to all of you. And I want to start by asking Dr. Eza first, if you could define what artificial intelligence is in the context specifically of defense and battlefield thinking, and how you see it playing a role in the future battlefield of the next decade.
Yes, thank you so much for having me today. So the traditional definition of AI is the ability of computer systems to solve cognitive problems and tasks that typically require human intelligence, such as learning, reasoning, and pattern matching. Many advances in AI in recent years have been in a subfield of AI, of machine learning, particularly deep learning. This has largely been driven by access to massive data sets, open code libraries and tools, increases in storage capability, and cheaper hardware for processing. Machine learning is just one area of AI, and others include methods to organize and reason about knowledge, communicate across distributed AI systems, AI hardware, and how to effectively team humans with AI agents. Nearly all AI today falls under the definition of narrow AI, meaning that it is able to perform under the narrow tasks which with it has been designed. Future systems may be able to demonstrate more general AI, meaning that they can generalize to new situations and tasks. AI in the battle space is often thought of as something that's 10, 20, or more years in the future. But in fact, it is reshaping the battle space today. And there are really two paths by which AI will affect the battlefield. First, it will augment existing systems to enable them to respond to a challenging adversarial environment at the speed of the mission. For example, it will enable intelligence, surveillance, and reconnaissance ISR functions to occur on the edge and across sensors and platforms. It will increase the ability of platforms for maritime surface vehicles to land and air platforms to identify and defend against new threats that have never been seen before. It will enhance logistics and sustainment for predictive maintenance. Secondly, AI will provide revolutionary capabilities to new systems. These include swarming systems, highly autonomous vehicles, and intelligent communication systems that connect capabilities across domains. AI and cybersecurity will quickly identify and eliminate cyber threats, adversarial attacks on AI, and disinformation campaigns. Underlying all these capabilities will be AI in wargaming, using techniques such as reinforcement learning to develop new strategies that will play out in the battle space. In short, AI is going to affect every aspect of the future battle space. Thank you.
Dr. Eza, thank you so much for giving that kind of overview. It's most helpful as we kind of head into this discussion. And I'm very conscious that on the panel we have this range of expertise from different perspectives within the defence industry. So I wanted to ask each of you, perhaps starting with Nabil Lodi, if we're very aware that this is, for those who aren't already working in the defence industry, it's a big shift from hardware thinking to software thinking. And I wonder how you could give a bit of insight into how best to use AI in the defence sector in decision making and kind of harnessing intelligence and data.
I think it's not just moved from hardware to software, but actually now down towards data. It's all about data. So rather than thinking from a software or IT perspective, you've got to really understand what the problem space you are in, and therefore what data is required for that. And then you start to be able to drive the sort of data requirements. And to really revolutionize it, we've got to change the way we look at data. You've heard a lot about interoperability. That's great, but what does that actually mean? And it's about those siloed data sources from within the organization, from external, from open source, social media, IoT sensors. That's the sort of level of data that no human is able, in the sort of speed we're talking about now in the battlefield, to assimilate and make predictive decisions. So if you can get that right, the algorithms that sit on top of that will actually revolutionize our thinking. And as Netta just said, it can go from everything from something that is assisted, augmented decision-making to autonomy. And the real revolutionized thinking is when you have a system of algorithms where it makes the decisions on what data is required and governs itself. That's where we will shift. But right now, the real challenge and cultural change, because this is about cultural change, is getting that data right. And we've got to really understand that that is a problem we need to face.
I want to ask each of the rest of the panellists to kind of give us a bit of insight into, from your corporate perspective, how you see AI and the challenge that lies ahead. So perhaps Mike Stewart next.
Yeah, sure. I think there are many challenges around any form of emerging technology, really. And I think with artificial intelligence, it's how to demystify that in a way that actually adds operational value to the battlefield. I think one of the things that we're really focused on within Kinetic is that mission-led innovation aspect. So, technology is there to enable, but we all need to be sort of like focused on the mission in hand. And I think that, as we've heard earlier on today, is all about the wider ecosystems. It's about working together. It's about getting diverse thinking. And it's about culturally just changing the way that we work as well. And I think quite often, we obsess about the technology, but the behaviors, the ways of working are just as important as the technology itself. There's no doubt, though, through the use of artificial intelligence, that adding AI software, machine learning software to existing assets can add and help operational value. But it just needs to be teamed together in such a way that there's a partnership between the technology and the existing equipment.
Paul Gosling, your thoughts on this, and indeed, if you can give any examples of how you're using AI.
Well, I mean, starting from a sort of a background in a business where sonar systems produce a vast quantity of data, it's very evident that we need improved algorithms to sift through the amount of military data that we see from our systems today to help the operators. I think we're already in a situation where military operators are just overloaded with data, but not necessarily with the essential information. And I think Netta gave a perfect example of the demonstrating, perfect definition of AI. I see one of the challenges we have, though, is as we go from weak AI to stronger AI systems, we need to still make use of the fact that we have to be able to explain the decisions the AI systems are making, be sure that we trust them, and those are going to be some real challenges we face. And even today, with very simple algorithms we use in our systems in service, when you put a human operator in front of an automated system, you have to be very careful that they question and don't automatically trust the output of those systems. So it's a significant challenge to team up AI type systems with the traditional man-in-the-loop systems that we have today.
It's so interesting that you gave the example of the human interaction, needing to be told not to automatically trust, which really reveals that kind of complex challenge of what AI can do and what it can potentially cause harm to. Alan, what are your thoughts on the use of AI?
I think with something that is actually so ill-defined as AI, because actually AI, the definition for AI that the doctor gave was a good one, but it's a definition that has evolved over time. And I think one of the challenges that we need to face up to is that because of the ill definition of it, it does attract quite a lot of hype as well. There is some enormous capabilities that can be provided by AI, but there is also a lot of hype associated with it. So I think one of the challenges in defense is, as my colleague to my right said, is recognize the utility of AI applications within the wider context, also to debunk some of the hype that may surround it.
Could you debunk some of the hype for us right now, just in an example?
Well, I think the concept of this general intelligence, this all-seeing, all-pervasive human intelligence is still quite some way off.
The singularity.
The singularity,
yeah.
Yes, is quite some way off. I think, as my colleagues have said, there are definitions around narrow, well-constrained, very specific tasks that AI can accomplish, and it does it extremely well in those circumstances, beating human operators quite often. Games of chess, games of Go, that sort of stuff, but we're not in the gaming industry. We are in a serious business, and so one of the concerns I have is building up that level of trust, not just between ourselves and our direct customers, but also between our allies as well, because without that level of trust and understanding of what is achievable with AI, then I think actually a lot of it will be lost, a lot of the good work will be lost.
And thank you for raising, all of you kind of hinted at the ethical challenges straight away. Dr. Ezra, one more specific thing to you. So military autonomous systems and their development has been, I think it's fair to say, relatively slow and incremental in comparison to, when we think about commercial autonomous systems such as kind of drones, driverless cars. Could you briefly give us a sense of how technology like this, which is being developed in the private sector, can be applied to national and international security and defence?
Yeah, so the first thing I want to note is that the DARPA driverless car Grand Challenge was one of the critical forces behind the acceleration and realization of commercial driverless cars today. While back in 2004, not a single car made it through the 150-mile routes, it really sparked an entire industry and excitement across nations for the possibility of autonomous vehicles. And today we're seeing that similar competitions and challenges are bringing various industries together, including traditional aerospace and defense companies with companies that have never worked in the military space, collaborating to meet these challenges for swarming, underground autonomous vehicles, and maritime autonomous vehicles. So I think the key here is bringing those companies, the various subject matter experts and mission experts together to enable these capabilities and transition them from a commercial space to the military application. Now, there are a number of technologies in the commercial autonomous systems arena that are able to transition to accelerate adoption into military autonomous vehicles. But there's also some real hurdles. So in terms of the technology, there have been numerous advances in things like computer vision for collision avoidance. There's also been new sensors such as LiDAR that are increasingly cheap, capable. Cloud infrastructures enable large-scale management of fleets, as well as rapid pushing of new code updates. And gaming engines provide the ability to quickly create scenes and environments to train artificial intelligence, as well as test autonomous vehicles. Now, there are some challenges, too, in terms of that technology transition, and I point to just a few of those. First, commercial companies have largely focused on the visible spectrum, whereas defense encompasses numerous other areas of the spectrum and sensing. Commercial autonomous vehicles also operate within an environment that has common signage, and indicators such as stop signs and roadway lines, as well as accessible communication networks, which are not always the case when looking at military platforms. And the key thing here is going back to the comment about bringing commercial and defense companies together. This is where collaboration is really critical to be able to mission these commercial technologies and bring them into the military, defense, and security applications. Thank you.
Thank you. I wonder if any of the other panelists would like to kind of pick up on that. Alan first.
Yeah, I think one of the challenges, I mean, facing the defence community is that we cannot easily match the pace of change that is happening in the commercial sector, but they are developing capabilities which are to a different standard in terms of certification, verification, validation, that sort of stuff. I think the concern for me is we should be developing strategies in which we can harness those where they have true utility, but to contain them in a way that basically that any mistakes made and things like this can actually be contained and dealt with. So we need to be developing strategies on how we can exploit those commercial technologies and embrace them, but surround them in an environment that allows the particular peculiarities of the military context to be considered.
Thank you. Does anyone else like to contribute on this? Paul, do just chip in if you would like to, as though you're not in the room.
Yeah, I think I'll just echo the same point, really. I mean, the standards that we have to follow in terms of safety and security of military systems do tend to sort of raise the bar quite a lot in terms of what we can and can't do. But nevertheless, you know, I think those of us who've worked in the defence industry for many years will recognise that in the past, the defence side of things tended to lead in some of these areas, but I think increasingly we find that the commercial technologies are getting there first, and so we certainly shouldn't ignore the benefits that we can draw from commercial technology. So certainly if you look at things like computing, for example, you know, many years ago, military systems have very bespoke computing environments. Nowadays, most of them are using off-the-shelf computers that the civil market uses. So I see the same evolving in this area, but we're not there yet.
Thank you. Mike next, and then Nabil.
Yeah, so I'll just raise a slightly different sort of view of this, really. Artificial intelligence has application across multiple industry sectors, not just defence, of course. And I think the real challenge with that is there is a battle for talent that exists. Why would I work in defence versus why would I work in retail or work in financial services or other sectors? So it's the same fundamental talent group that we're all trying to leverage here. So I think when we're thinking about those collaborations, it is difficult. If you've got an organisation that's building a navigation system for the automotive sector is a much more attractive sector because it's bigger than the defence sector. So how do you actually take some of those technologies out of those other sectors and pivot them into defence? And I think that has to be done by collaborations. It has to be done by organisations like ours, represented here, changing how we think and acting differently to be more collaborative in general. And then I think we have to consider the psychology of collaboration as well, and really what is motivating the collaborations, and so that, you know, we're actually all focused, as I said earlier, on that mission, on that common goal together.
Yeah, and what should motivate those collaborations, of course, as well. Nabil, your thoughts on this?
Yeah, I mean, I'm approaching this from an SME, and probably I think the only SME that's been, involved in this event. It is different from, AI machine learning is an area where there is a vast amount of talent that is out there, and it's not being harvested by the defence sector. And whilst we're seeing changes in, First Sea Lord announcing this, the tech bridge yesterday, I think it's the same for the strategic partners as well, to be able to, those ecosystems, how to actually turn those ecosystems something that is real, where actually all the SME talent, the digital talent in this country can be harnessed for the defence sector.
Well, that's useful to know. Right, question I want to direct first at Mike. Many argue that AI could increase the risk of war. We've already seen some of the very, very negative news coverage around the use of drones, that it could escalate ongoing conflicts, it could increase malicious actors. How do we ensure that AI doesn't become a threat multiplier?
Yeah, no, there's a number of aspects to that. So one of the things that I'll just illuminate really is a school of thought that's developing in the field of AI called explainable AI. And I think the challenge with artificial intelligence is if you've got a black box-based thinking model, you provide it an input, an outcomes, an output, and you don't really understand, what's happening inside. So in order for us to sort of like get to the bottom of the more challenging and ethical and legal issues associated with artificial intelligence, explainable AI is really about providing interfaces that actually illustrate the decision-making logic that the machine has actually computed in order to come up with the outcome. And I think it's things like that, movements like that, which are becoming increasingly more important than achieving the original goal.
And I'm going to ask any other panelists to respond. I'm going to include in this one of the audience questions that's come in. How do we develop trust in AI decisions, which is part of that issue that goes with the concern. Who wants to take it next? Yes, Nabil.
It's back to the data. The decisions that humans make and bad decision is down to bad data or missing data because they've got to make a decision within a certain timescale. AI algorithms are doing exactly the same. They're just doing, using a lot more data. So therefore, to ensure that those decisions are, the same decision that an AI algorithm is making on this side of the Atlantic than the other side of the Atlantic, it comes down to that data that they're using. And therefore, what we call the lineage, to be able to trust that data, that is absolutely critical. The algorithm will just use the data it's been given.
Okay, Alan.
I mean, many of these AI systems are in effect trained, and the quality of the training that is applied is down to basically the quality of the data that is available. So if there are inbuilt biases in either the data, then you could end up building in biases in the decision-making process in that AI algorithm. And that has been clearly shown in AI applications used for things like triaging parole cases in the US and things like this. Real biases, racial biases. So you could actually perceive this instance where there are two AI capabilities pitted up against each other, each with opposite biases in it. The escalation route will be dramatic, it will be quick, and will probably have limited opportunities for intervention for safeguarding. So if not properly approached, potentially, yes, it could escalate the situation quite dramatically.
Fantastic. I'm going to go on to the next question, and can I ask my remote guests, as obviously you don't have the advantage of being able to catch my eye, if you want to just give me a little wave if you want to come in on this one. Earlier, Jeremy Fleming, the head of GCHQ, preferred to refer to cyber operations as opposed to offensive cyber. Does the same apply to AI, or are we being too cautious and not sufficiently adversarial, which I think is very interesting way of framing it. Dr. Eze, you're looking thoughtful. Can I bring you in on this?
So I think there's a lot of awareness that there are adversarial attacks to AI, either by creating things like deep fakes, which represent videos or imagery that have been developed artificially to, for example, show a person saying something that they haven't actually said. It can be very difficult for a human to be able to detect these deep fakes. I think we need to be aware of the implications of these. We need to test and secure our own AI systems against adversarial attacks and poisoning, and have it be part of the process in developing these systems to ensure that we're not opening up our AI systems for these sorts of attacks. We're seeing a lot of misinformation campaigns from adversaries exploring these techniques. And again, we need to be aware of them, prepare for them, and really make sure we're securing our AI systems.
Thank you. Would anyone else like to take this on? Yes, Alan.
Yeah.
Oh, Paul, go first. Absolutely, Paul.
Yeah, so I think just to add to what was said there, I mean, military systems in the general, we go through a fairly rigorous qualification process. And I think one of the things that AI and things like autonomous systems do is they challenge the established way we follow with qualifying systems. And so I think one of the things that we do need to do for AI systems is to look at the most robust way of being able to assure that they're both safe and secure. And I think some of our established methods of doing that will need to evolve in order to cope with the sort of things that we see with cybersecurity and clearly the sort of the interaction with man and machine in the way that AI does.
Paul, can I ask you more specifically, do you have ideas of ways that the US and the UK could collaborate to enhance these AI technologies but ensure their ethical and responsible use?
Well, certainly one of the areas that I think is generally seen as an area of work in this area is the whole concept of digital twinning. So whereby you have massive simulations of the AI systems so that you can prove them in the virtual world before you prove them in the real world. And I think there is certainly a lot of interest in looking at what we can get out of digital twins in this area.
Thank you. Alan, a specific question for you. Are autonomous weapons the future of warfare, and how should the development of this technology be controlled?
I think it's almost without a doubt that autonomy at some level will feature in the future battle space. We're dealing with concepts on programs like Tempest, where we've got swarms of adjuncts working alongside the core platform and things like this. So autonomy will absolutely be a feature in the future battlefield. I think the issue around controlling this sort of proliferation of technology or capability is a real challenge, because we are not the only dog in the race. China, Russia will be developing these sorts of capabilities. And so, we've seen examples, particularly with UAVs, where we've possibly, in an overzealous way, tried to...
UAVs?
Unmanned aircraft.
Thank you.
Where we've tried to control the proliferation of that technology in perhaps an overzealous way. All that's actually done has meant that some of our potential adversaries has proliferated that capability themselves. So, one of the challenges to us is to work with our governments and things like this to try and prove that the proliferation of this technology needs to be done in a way that is in a controlled manner, under influence of our government-to-government relationships and things like this. But to try and control the proliferation of technologies from adversarial countries like China and Russia, it's just not going to happen.
Yeah. Right. Final question, which I think is very popular in our audience. I'm going to put it both to Mike and Nabil. Are we focusing on applying AI on the end user in war fighting when it may be better used in improving the supply chain or logistics, so reducing the cost of procurement, which has equal benefit? Do you want to take that first, Nabil?
Yeah, I think we've got to use AI just across the whole field of defence. And that's everything from financial decisions, logistics, all the way to the warfighter. So I think it's already across everything we do, from recommended actions to autonomous decisions. I think where we need to go to is a cultural change to say, actually, where we use AI for outcomes, that's the bit where I think we could really, really focus attention to say, you've got a system of systems of AI and allow them to make the decisions of where we want to get to. And that's very different to using AI for specific tasks. That's already there, and we just need to go back to it, get our data straight so they can really deliver benefit. The one thing I think we should do all the way across is, and as Alan said about the hype, is return on investment. It's really simple. What's happening before? What's happening after? What's the cost of doing that, and how much do you save? And if you can't get that return of investment right, you're not going to be able to scale and operationalize anything from logistics to warfighting.
Mike, what are your thoughts on this issue?
Well, I think my thoughts are, we can't boil the ocean, so to speak. You can apply artificial intelligence to lots of stuff. I mean, in the home at the moment, you've got all sorts of devices. Most of them are, useless devices nowadays that give you some form of technology, and you think, oh, that's great. But, that's because we're not sort of prioritizing the mission. So I would go back to, irrespective of whether you're looking at front-end services or back-end services, it's really a case of being really clear what are the priority missions that we want to apply the technology to. The technology is there and can be integrated and applied to those missions, but you can't do everything at the same time. So I think if we're clear about the focus, clear about the missions, then I'm sure that the ecosystems can come together, collaborate with the joint outcomes in mind.
Alan.
I think some of the most graphic examples of AI algorithms are things like the recent DARPA Alpha dogfight trial where the AI algorithms developed by a 30-man company was pitted up against an experienced pilot, and he lost 5-0. He didn't even stand a chance. The trouble is, actually, some of the nearer-term benefits that could be achieved through AI are much more the sort of backroom tasks, the prognosis, the diagnosis of faults, the preempting of maintenance on platforms and things like this. The ability to field more mission-ready assets will be a tremendous force multiplier now.
Yeah, well, what I love is that a question from the audience absolutely elicited, a whole new way of thinking beyond the more basic question about AI. I'd like to thank all my panelists for their contributions. I wish we had more time, but I think we covered a lot of ground in the time that we did have. So thank you very much. And we'll now have our final networking break of the day, where Fraser Nash and Kinetic will be hosting their thematic networking sessions in their strategic partner booths in the Expo Hall. I urge you all to explore these on the online platform, and we'll be back in 20 minutes for our final panel, which is about the integral part space will play in our futures.